is similar to stuff you've done before. I heard someone say FOIL. It's actually a lot like FOIL. FOIL is just one very specific type of polynomial. This is more general that you can use for everything. Thinking back to chapter 7, when we talked about like the properties of exponents, when you're multiplying two powers together, what do you do with the coefficients? And like, for example, if I gave you this example, what would you do with the 3 and the 4?
Plug them in.
Multiply them, right? So you multiply the coefficients.
And then do you add the exponents?
That's right. You multiply coefficients, but add exponents.
Is this math?
Yay,
This is kind of like P-Man. Is that what you're thinking of? Oh, okay. So you multiply coefficients, add the exponents. So what would this turn out to be?
12 to the power of 7.
So it would be 12x to the 7th. Okay. The big key to multiplying polynomials, and there's a couple different ways you can do this to keep it straight, is multiply everything by everything. And you'll see what I mean by that in just a minute. And to help you kind of remember that, or remember what that means, I want you to jot down the distributive property and FOIL. Because really FOIL is just a fancy acronym for the distributive property. But that's what this is all about. This is all about distributing over and over and over again. Okay? I'll be honest with you, these problems can get a little bit tedious, but they are not difficult. They should not be hard for you. Okay? So FOIL works when you've got two binomials. So if I had x plus 4 and x minus 7, for example, you would do first, outside, inside, last. Right? Does that sound familiar?
Yeah.
This is going to use the same type of process, but the acronym FOIL won't work anymore because you're going to have more than 2 by 2. So, like in this first one,
I got a question.
yep, go ahead.
So basically all you do is like you go from left to right multiplying like each one.
Exactly. Yep. So you're going to take this x squared and hop over to the other parentheses. So you're going to do x squared times 2x to the third. What would that give you? 2x to the 5th, yep, because this is really a 1. 1 times 2 is 2, and then you have 5 x's total. Then I would take that same x squared and go over to the minus 4x. So that's going to give you minus 4x to the third. Everyone see why it's, excuse me, why it's x to the third?
No.
Okay, I have 1x here and 2 x's here. So when I multiply together, I have a total of 3 x's.
Okay, so then where did you get the, so where did you get the 2x from?
Okay, up here, this one,
Yeah.
I did x squared times 2x to the third. So 1 times 2 makes 2.
FOIL? Oh.
Yeah, it's like FOIL.
I know what you're using for.
Yep. So now I'm going to go to this 3x.
First.
And for the 3x, I'm going to do 3x times 2x to the third. That's 3 times 2 is 6. And then I have 4 x's total. And then 3x times negative 4x would be 3 times negative 4 is negative 12. And x times x is x squared. Yep. So then I'm going to go to my negative 1, and I'm going to distribute that. So negative 1 times 2x to the third is negative 2x to the third. And negative 1 times negative 4x is going to give me positive 4x. Yep, just a second, I'll get there. Okay, so all I'm doing there is taking everything in that first parenthesis and multiplying it by everything in the second parenthesis.
I got it. I got the answer.
Okay, hold on just a second. What I would do at this point, or what I would do as you're going through this, because the problem is you can get disorganized. And if you start just kind of randomly multiplying things together, you might miss something. So I would do it either how I just did it, Okay, where I start with this term and I multiply it by everything, and then I go to this term and I multiply it by everything, and then I go to this term, multiply by everything. Or I'm going to show you another method down here with a box that you can use. Now what we need to do is combine like terms. And remember, they're only like terms if they have the exact same exponents. Where do you see things with the exact same exponents?
3.
Okay, so I have a negative 4x to the third and a negative 2x to the third. And I would write your answers in standard form when possible. So I would start with this 2x to the fifth. Nothing that can combine with that, right?
No.
Okay?
Right.
Then I would go to my x to the fourth. And nothing that can combine with that, I don't think. Nope. Then I would go x to the third and I would combine those. So what's that going to give me total? Negative 6, x to the third.
So you would just subtract the two numbers, not the.
Right, because that's like this many x cubes and this many x cubes. How many do you have total? You have negative 6x cubed. So when you're adding and subtracting, the exponents don't change. Okay? And then minus 12x squared and plus 4x. Okay? That's what your final answer would look like. Good? Not hard, right? Just kind of takes a while. So let's look at number 2, because number 2 we get into some problems with multiple variables. What I would do with these, when you're multiplying two different variables together, as you write it down, as you write down your answer, I would put your letters in order alphabetically. Okay? And if you always do that, then you'll be able to spot common or like terms more easily. Like if you had something with an x and a y, and you wrote one of them as xy and then another one as yx, mathematically that's okay. But you might not realize that they're like terms that could be combined if they're written out of order. Okay, so I'll show you what I mean by that. Let's start with this first one. If I do 4r cubed times 8pr to the fifth, I would do 4 times 8 is 32. And then I would go to the p, because the p comes first alphabetically. There's no other p's to combine with over here, so I'm still just going to have one p. And how many r's total? 8, yep. Okay, so that's going to be 32pr to the 8th. Go back to your 4r cubed, and we need to multiply by this middle term. So 4 times 6 is 24. Again, I would go to my p first. I have 3 p's, p cubed, and 5 r's, so that would make r to the 5th. Okay. And last one, 4r cubed times negative 5r. 4 times negative 5 is negative 20. And I would have 4 r's total. Okay, so that's I just did the first term so far. Now on to the second term, negative 3p squared r squared. So when I multiply these, negative 3 times 8 is negative 24. P to the third, r to the 7th. Yep. Then I'm going to go to the next one. So negative 3 times 6 is negative 18. P to the 5th, r to the, yep. And then last one, negative 3 times negative 5 is positive 15. I would have p squared still, and r to the third. At this point in the game, I'm not going to make you write this in standard form because it works a little differently when you've got more than one variable. So you don't have to worry about standard form. But you should look and see if you can combine anything.
You can't,
You cannot. Why not?
because there's no like variable.
Okay, but what about, like I have 24p to the third here and I have 24p to the third here.
The r's are different.
Good. Yeah, you've got to have the exact same letters with the exact same exponents. So like these could not combine because the r's are different. Okay, you can't combine this with this because this one has a p in it. So they would have to be the exact same letters, exact same variables. Good? I think the hardest thing about this is just keeping your pieces organized. So So let me show you one more method, and then I'm done talking at you for today. Okay? If you're getting confused with writing out your terms, if you're getting confused what goes with what do I multiply next, and so on, you can use this box method. And I don't remember if we talked about this back when we did FOIL or not.
No.
Okay. I usually find that it makes FOIL harder. Maybe not harder, but it takes longer than it really should for FOIL. But for this, sometimes it's a little bit easier. In this problem, see how I have 3 terms in the first one and 3 terms in the second one?
Yes.
So I made myself a box that was 3 by 3. And now I'm going to take these 3 terms and put them along the top. So the first one would be 6a to the third b squared. The middle one would be negative a squared b. And then my last one would be 2b to the third. Okay. And then down the side, I'm going to put these 3. So this would be 7ab, 5a squared b, and a to the fourth. Everyone okay with how I did that? I want you to write this one down the way I'm doing it, and then when it comes to your homework, you can decide if you want to do it kind of with these rainbows, or if you want to go back to the box. Okay? Now I'm just going to multiply. So I'm going to do 7ab times 6a to the third b squared. So I'm multiplying these two. That would give me 42 a to the fourth b to the third. Any questions about where that came from? Make sure that makes sense to you.
Wait, you did 7 times, oh no.
7 times 6, and then I had 4 a's and 3 b's. Now let's go to this one. So 7 times negative 1 would give me negative 7. Total, I would have 3 a's and 2 b's. Okay. What would I get when I multiply these two? 14 a b to the fourth. Good. Then I'm going to go down to this set. So 5a squared b and 6a cubed b squared. What would that come out to be? 30 a to the fifth, because I have 2 here and 3 here, so 5 total. B to the third. Does that make sense? Okay. And then here, 5 times negative 1 would be negative 5. A to the fourth, b to the second. Good. This would be 10. A squared b to the fifth. Yep. One more row, I guess I should say. So this one really is just going to get 4 a's tacked on to everything. So this would become 6. Oh, on the last one? You're right. Thank you. Thank you. Okay, sorry. Moving on to this one already. That would be 6a to the 7th b squared. So I'm just taking 4 a's and adding them on to everything. This would become negative a to the 6th b. And this would become 2a to the 4th b to the 3rd. Okay, so again, just another organization way to put those all together. Do you see any that I could combine? I feel like there was one in here. Let's see if we can find it. Here we go. 42a to the 4th b cubed and 2a to the 4th b cubed. Do you see that those have the same exponents?
Yeah.
So those ones go together. Are there any others? I don't think that there are. Okay. Again, I'm not going to stress about you doing standard form here because standard form is tricky when you have 2 variables. If you know how to do it, go for it. If not, just list everything out because we do need to write our answer out like one of these. So I'm going to go ahead and combine these two. That's going to make 44 a to the 4th, b to the 3rd. Okay. Then I would go negative 7a to the 3rd, b squared, 14ab to the 4th, 30 a to the 5th b cubed. I'm just going to go on down here. Minus 5 a to the 4th b squared. Plus 10 a squared b to the 4th. Plus 6 a to the 7th b squared. And then minus a to the 6th b. Whew. There's not going to be a ton of them that I ask you to do that are that big. But I wanted you to see that that same process works. Okay? Does that make sense? So you could have done this just like we did the other ones with the little rainbow bars. Just sometimes when they're bigger ones like this, it's easier to arrange them like that. Cassidy? These two here, do you see how they had the exact same exponents? A to the 4th, b to the 3rd? So I added those together. 42 and 2 makes 44. Well, at the end here, when you write out all of those terms, you're adding all of those terms together. We already multiplied to get those. Now we're adding all the pieces together, and those two pieces I could combine. Does that help? Okay. Let's try some homework on that.